A seed that thrives where corn dies, a bean that needs 1/4 the water yet delivers twice the protein. This is not science fiction. This is Tepary. For over 4,000 years, indigenous peoples of the Sonoran Desert cultivated a crop so resilient it could survive months without rain, yet modern agriculture erased it from existence. We replaced survival with convenience. We traded genetic wisdom for uniformity. Today, the shelves overflow with beans bred for appearance, not endurance. But in the harshest corners of the American Southwest, this ancient legume still grows wild, waiting. It refuses to die. The Tepary bean contains a biological secret that industrial agriculture desperately wants us to forget. While hybrid crops demand irrigation systems, fertilizers, and constant intervention, this plant simply exists. It extracts nitrogen from barren soil. It flowers in blistering heat. It matures in 60 days. The system told us that high yields require high inputs. The Tepary bean proves that narrative was always a lie. Survival is not about control, it is about adaptation. And this seed has been adapting since before empires rose and fell. The protein content of Tepary beans reaches 30%. Read that number again. Beef averages 26%. Chickpeas offer 19. Common pinto beans barely reach 21. Yet somehow, this nutritional powerhouse vanished from grocery stores, seed catalogs, and collective memory. The erasure was not accidental. Industrial agriculture demands crops that behave predictably, mature uniformly, and ship without bruising. The Tepary bean refuses to cooperate. Its seeds vary in size and color. Its vines grow irregularly. It cannot be harvested by massive combines designed for monoculture. So the industry chose elimination over adaptation. They called it obsolete. They called it unmarketable. What they really meant was uncontrollable. This bean contains all 9 essential amino acids. It delivers more calcium than milk. Its fiber content supports gut health that processed foods destroy. The nutritional profile reads like a manifesto against modern food. But here is the darker truth. The Tepary bean was not replaced because it lacked value. It was replaced because it offered too much independence. The Tepary bean evolved in one of the most unforgiving climates on Earth. Summer temperatures in the Sonoran Desert exceed 115 degrees Fahrenheit. Annual rainfall barely reaches 10 inches. Most crops require 20 to 40 inches. Yet Tepary thrives. Its roots plunge deep, seeking moisture where other plants find only dust. Its leaves possess a waxy coating that minimizes water loss. Its flowering mechanism activates during brief desert monsoons, then races toward maturity before the soil dries again. This is not luck. This is 4 millennia of genetic refinement. Indigenous farmers did not breed this bean for supermarket shelves. They bred it for survival. They selected seeds that germinated in drought. They saved plants that produced despite adversity. Each generation became more resilient. Each harvest encoded another lesson in biological wisdom. Modern breeders call this primitive. They prefer laboratory manipulation, genetic shortcuts, and patented seeds. But when climate change arrives, when aquifers run dry, when the irrigation systems fail, which seed will still grow? The answer grows wild in Arizona. The disappearance of Tepary beans from American agriculture was not natural selection. It was economic engineering. During the 20th century, federal subsidies poured billions into corn, wheat, and soybeans. Research universities focused exclusively on high-input crops. Seed companies patented varieties that required chemical packages. The Tepary bean offered none of these profit vectors. It needed no irrigation beyond rainfall. It required no synthetic nitrogen. It resisted most pests naturally. For industrial agriculture, this was not an advantage. This was a threat. A crop that thrives without corporate inputs cannot generate recurring revenue. A seed that farmers can save and replant cannot be patented and controlled. So the system did what systems do. It marginalized the alternative. It funded research on crops that demanded intervention. It flooded markets with subsidized commodity beans. It made the resilient option economically invisible. Today, Tepary beans occupy less than 5,000 acres nationwide. Soybeans cover 83 million. The market has spoken, but markets are not neutral. They are designed. The flavor profile of Tepary beans defies the bland uniformity of industrial legumes. There is an earthy richness, almost nutty, with subtle sweetness that intensifies during cooking. The texture remains firm even after prolonged simmering. This is not the mushy surrender of canned beans. This is structural integrity. Indigenous cooks roasted them dry, ground them into flour, or simmered them with chilies and wild herbs. Spanish colonists recorded that Tepary beans were served at ceremonial feasts, prized above imported foods. The taste was distinctive enough to merit documentation. Yet modern palates have been trained on sameness. We expect beans to be background texture, not primary flavor. We accept blandness as normal, but normal is not natural. It is manufactured. The Tepary bean reminds us that food once had character, personality, terroir. Each variety carries genetic memory of the soil it evolved in. White Teparys taste different from brown. Desert-grown differs from mountain-grown. This is what industrial standardization destroyed. Not just nutrition, not just resilience. Complexity itself. Growing Tepary beans requires almost nothing. No tilling necessary, no fertilizers required, no irrigation systems. Simply plant seeds after the last frost in well-drained soil. Spacing can be tight. These beans evolved in competition with desert shrubs and native grasses. They know how to claim their space. The vines will climb if given support, or sprawl if left alone. Either way, they produce. Flowering begins around 40 days. Pods form within weeks. Total time from seed to harvest, 60 to 90 days, depending on variety. Compare this to common beans requiring 120 days with consistent moisture. The efficiency is almost offensive to conventional wisdom. But here is what makes Tepary truly revolutionary. It fixes atmospheric nitrogen into the soil through root nodules containing rhizobium bacteria. This means the plant actually improves soil fertility while growing. No synthetic inputs needed, no soil depletion. This is regenerative agriculture encoded in genetic code, and we abandoned it for crops that require annual chemical infusions. The logic defies explanation, unless profit, not sustainability, was always the goal. The culinary applications of Tepary beans extend far beyond simple side dishes. Indigenous cuisines used them as primary protein in stews, dried and ground them into nutrient-dense flour for flatbreads, and roasted them as portable survival food during long journeys. Modern chefs rediscovering Tepary beans report that they absorb flavors magnificently while maintaining textural integrity. They work beautifully in refried preparations, hold their shape in salads, and create incredibly rich soups when simmered with aromatics. The key is treating them with the respect they deserve. Soak overnight in cool water. Simmer gently with bay leaf, garlic, and cumin. Season only after cooking to prevent toughening. The result is a dish with depth and character that canned beans cannot approximate. Some varieties benefit from dry roasting before cooking, which intensifies the nutty undertones. Others shine when cooked simply and dressed with olive oil and herbs. Each type has its ideal application. This is not convenience food. This is ingredient with personality. And personality requires attention. The genetic diversity within Tepary bean populations represents a biological library of climate adaptation. Researchers have identified varieties that withstand temperatures up to 120 degrees Fahrenheit. Others tolerate alkaline soils that kill most legumes. Some mature in 45 days. Others produce larger seeds with higher protein density. This variation is not a flaw requiring correction. It is resilience encoded across multiple genetic strategies. Each variety is a different answer to the same question: how do we survive? Industrial agriculture erased this library in favor of a single volume. They selected one uniform variety, optimized for mechanical harvest and visual consistency. They called it progress. But genetic uniformity is biological fragility. When a disease emerges, when climate shifts, when conditions change, uniform crops collapse simultaneously. Diverse populations adapt. They contain variants already equipped for new challenges. The Tepary bean gene pool is an insurance policy against agricultural collapse. And we nearly threw it away. Some seed banks maintain collections. Some indigenous communities still save traditional varieties. But the commercial market offers maybe 3 options. 3 answers where hundreds once existed. The story of Tepary beans is inseparable from the story of indigenous agricultural knowledge systematically devalued and erased. For 4,000 years, Native American farmers in the Southwest developed sophisticated dryland farming techniques perfectly adapted to desert conditions. They understood soil microbiology, water harvesting, and genetic selection long before Western science claimed to invent these concepts. They cultivated Tepary beans not as a curiosity, but as a cornerstone crop, ensuring survival during drought cycles that would decimate European farming systems. Then colonization arrived. Federal policies forced indigenous peoples off ancestral farmland. Agricultural extension services promoted irrigation-dependent crops. Universities ignored traditional knowledge in favor of chemical-intensive models imported from wetter climates. The result was not just cultural loss. It was the abandonment of agricultural systems evolved for the actual environment. Today, the Southwest faces water crisis. Aquifers are depleted, rivers run dry, and the crop bred for precisely these conditions is almost extinct. This is not irony. This is the predictable outcome of agricultural colonialism. The solution existed before the problem. But the solution required acknowledging indigenous wisdom, and systems prefer collapse over acknowledgement. Climate projections for the American Southwest predict increasing temperatures, declining rainfall, and more frequent extreme drought events. This is not distant future. This is arriving now. Agricultural regions dependent on irrigation face existential crisis. The Colorado River cannot supply water to millions of acres indefinitely. Groundwater depletion accelerates annually. Conventional crops will fail. Not might fail. Will fail. The Tepary bean is not a nostalgia crop. It is a climate adaptation strategy growing in plain sight. It produces protein with minimal water input. It thrives in heat that wilts conventional beans. It matures fast enough to dodge drought. It improves soil rather than depleting it. These are not optional features for sustainable agriculture. These are requirements. Yet agricultural policy still subsidizes water-intensive crops. Universities still research irrigation-dependent varieties. Seed catalogs still feature beans bred for temperate climates. The Tepary bean is treated as a heritage curiosity, not a survival necessity. This is planning for a climate that no longer exists. The desert has always known what works. We simply stopped listening. Growing Tepary beans is not gardening. It is a declaration of independence from industrial food systems. Every seed planted is a vote against monoculture. Every harvest is proof that resilience matters more than uniformity. This is not about nostalgia. This is about building food security from the ground up, one drought-resistant plant at a time. The system wants you dependent on their seeds, their inputs, their distribution networks. The Tepary bean requires none of it. You can save seeds. You can grow without irrigation. You can feed yourself when supply chains collapse. This terrifies the people who profit from your dependency. So they made this knowledge hard to find. They removed it from agricultural colleges. They erased it from seed catalogs. They called it primitive. But primitive means adapted to reality. And reality is arriving faster than predicted. The choice is simple. Continue growing crops designed for a climate that is disappearing, or rediscover seeds bred for the climate that is coming. The desert already voted. It chose Tepary 4,000 years ago. Perhaps it is time we listened. The Tepary bean will outlive the corporations that tried to erase it. It will grow when patented hybrids fail. It will feed communities when supply chains break. This is not speculation. This is biological certainty. Every seed carries the genetic memory of 4,000 years of survival. Every plant is proof that nature's intelligence exceeds human engineering. The future of food will not be found in laboratories designing crops that require synthetic inputs. It will be found in seeds that already work, that have always worked, that simply need to be remembered. Some indigenous communities never stopped growing Tepary beans. Some seed savers maintained varieties when everyone else moved on. They are not relics. They are the vanguard. The revolution begins in the garden, not with grand policy changes or technological breakthroughs, with a handful of ancient seeds planted in dry soil, with the understanding that survival is not about controlling nature, it is about cooperating with it. The Tepary bean is waiting. It has been waiting. The question is whether we are ready to remember what our ancestors knew, that resilience is worth more than convenience, that adaptation matters more than uniformity, that some knowledge should never be forgotten. Plant the seed.